here, and we're here to record and teach about Unit 6, Day 3, classifying triangles. So far this unit, we've already done supplementary and complementary angles, as well as vertical and adjacent. Now we're going to talk about triangles. And as we all know, there's 3 angles in a triangle. So what properties do we know about triangles? How can we name them, classify them based on the angles within them? Okay. So, to start off, it says the angles of a triangle. Triangles are named by the 3 angles. Angles can be named in 2 different ways. Okay, so it starts off here. It says triangle ABC shown to the right. So here's triangle ABC over here. It says if I wanted to name angle A, which is right here, right? It's this angle right here. How could I name it? Well, there's 2 ways I can name it. I could name it CAB, because if I start at letter C and I go to A and then to B, CAB, notice how it creates that angle right there. Okay. Also, I could start at B. If I started at B, I would go BAC, and now I have, again, the angle where A is located. Notice how A is in the middle of both ways that I write it, whether it's CAB or BAC. A is in the center. That is where the angle is located in the triangle. All right, I'm going to erase this now. And now I want to look at angle B. Now if I want to know angle B, I start on one of its legs. ABC is one of the angle ways we can name it, but also I could start at C and do CBA. Again, both of them will give me the angle where B is located. Again, you can notice that B is in the center, and then the other side legs help us name this angle. I think by now you could probably do letter C or angle C. Start at A and do ACB, and then BCA. Again, the purpose of this is to determine different angles. So when I'm speaking or you're speaking, you can tell me what angle you're talking about. Okay. Another really important concept that we're going to be talking about is, it says the sum of 3 angles in a triangle is always going to equal 180 degrees. Remember that sum means addition. So if we add up angle A, angle B, and angle C, if we add all 3 of those, it'll always equal 180 degrees. It doesn't matter how big or small your triangle is, it'll always be 180. And we'll work with that more this unit. Finally, using information about a triangle and knowing that they add up to 180, you can set up an equation. We can set up an equation to determine if there's any missing angle measurements, that we could find out what those measures are. So that was about the angles, and now we're going to talk about classifying sides of the triangle. So again, the sides of a triangle. The side length of a triangle corresponds with the angle measure that's opposite the side. And I'll tell you what that means. Okay, over here we have triangle ABC. All right, and it says side AB corresponds with what angle? Well, again, let's see. We have side AB. The way it's written, I look at this side between A and B. That's the side, and it says it corresponds with the angle opposite. So the angle opposite is angle C. Right? It's opposite that side. Okay. Then side BC. Well, here's BC, and the angle that corresponds with that side is angle A. Okay. And finally, side AC. The angle that corresponds is opposite that side, which in this case, it's angle B. Okay. The smallest angle. Another interesting fact about triangles is the smallest angle is always opposite the shortest side of a triangle. So again, I need that to be bigger. Let's take care of that. Here we go. Okay. So what that means is that if I look at this, this is the shortest, this is the smallest angle between angles A, B, and C. A is the smallest. What that means is that BC is going to be the shortest side of the triangle. And then it says the largest angle, and if we look at these, if we were guesstimating, B looks like the largest angle, and that means the side AC is going to be the longest side. So knowing the angle measures will also help us know more about the sides. And also if we know the sides, it'll also tell us a little bit about the angles. Okay? Finally, a side is congruent to another side if it has an equal length. Okay? So congruent is basically a geometric term for equal or equivalent or the same. All those mean the same thing, right? But congruent is a word that we're going to use all unit in geometry about something that's equal to each other. Okay? They would be called congruent. All right, now what we're going to do is talk about triangles. Triangles can be classified classified according to their side lengths and their angle measures. So you can see here we have 6 names. We have equilateral, isosceles, scaling, obtuse, right, and acute. These are 6 terms that you want to become very familiar with. Okay? The first ones we're going to talk about are the side lengths. Okay? We could name or classify triangles based on their side lengths. So to start, an equilateral triangle. Okay, if you break down this word, we see equa, which we know probably means equal, and lateral is talking about the sides, so equal sides. So if I have equal sides, that means all sides are congruent, but I'm going to write equal just because I don't have enough space here. And if I drew a picture, it might look something like this. These little lines indicate that each of those sides that have one hash mark are each the same length. So all 3 of them have the same side. That's equilateral, right? Then we're going to talk about isosceles. Okay, isosceles would be when there are 2 equal sides. Okay, and because there's 2 equal sides, there's also going to be 2 equal angles. Remember we talked about how sides and angles correspond with each other? This is what it would look like. Here we have a triangle. This side and this side are equal to each other, which means their opposite angles are also going to be equal to each other. One thing I forgot to mention with congruent, there is a symbol that means congruent, and it looks like this. It's an equal sign with a little wave on top. Okay? Well, that was a bad example. Here we go. That means congruent, so I'm going to start using that instead of equal while I'm writing these down. Okay? Finally, we have a scaling triangle. A scaling, so if we have all sides are equal, 2 sides are equal, we also could have a triangle where there are no congruent sides. Right? And that could look something like this, where all the sides have a different length. Okay? Perfect. All right. Now we're going to classify triangles. Those were all by the side lengths. Now we're going to talk about their angle measures. Okay? We can classify angle measures based on one is called an acute triangle. You've heard of acute and right and obtuse when we talk about angles. So an acute triangle is when there are 3 acute angles within the triangle. Well, I just wrote that twice, angles. Okay, and maybe you might see a triangle kind of like this, where all 3 angles are smaller than 90 degrees, right? And maybe I'll write that this is less than 90 degrees, all of them. Okay, then we work the right triangle. That means there's a 90-degree angle, so there is one 90-degree angle within the triangle, right? And when we draw a picture of that, it might look something like this, where there is a right. Notice that we write a right angle using a box. You've probably seen that before. That means 90 degrees. Okay, but there's one 90-degree angle. And then finally, an obtuse. We know an obtuse angle means it's greater than 90 degrees. Okay, an obtuse angle is greater than 90. So you have one angle that is obtuse. And the way that could look is maybe something like this. Oh, sorry. That is a obtuse angle within a triangle. Okay? So again, we have 6 terms here that we are learning of how we title or name triangles based on sides or angles. All right, go ahead and flip it over to the next page. The next thing we're going to do is kind of use what we've learned to help us name different parts of a triangle or solve different parts of the triangle. So starting with number 1, it says, use each of the images above to answer the questions about the angle and the side length. So letter A, it says, which side corresponds to angle MNO? So I'm looking for an angle, right? I have to find M, and I go M. Oh, that's the wrong way. I got to go to M and trace to N and to O, right? And it says, which side corresponds? Well, this is the angle, and the side that corresponds, remember, is opposite. So in this case, side MO. MO. And when we do a side, we'll put a little line above it, and that indicates that's the side length or side leg. Okay, MO would correspond with angle N. Okay, now let's look at the next one. It said, which side corresponds to angle TUS? So first we need to find angle TUS. I trace from T to U to S, and I'm working with this angle here. It says, what side? The side opposite that angle is ST with a line over the top. ST. Okay, letter C. Which side corresponds to angle VXW? VXW. I trace it as I see it. Here's my angle. The side opposite of that angle or corresponding is VW. Perfect. All right, now this gets a little bit different. So now it says, which angle will be the smallest in the triangle of PQR? So first I need to look at triangle PQR, okay? The smallest angle needs to be the smallest degree. Well, we know this one is, angle P is 41.4, and angle R is 77.2. What we don't know is we don't know what angle Q is. It looks like it could be close between angle P and Q with which one is bigger or smaller. So we have to think, how could we possibly find this out? Well, we know that all the angles P plus R plus Q added together equals, we talked about this, 180 degrees. So if I were to plug in, my angle for P is 141.4 plus angle R is 77.2 plus Q equals 180 degrees. Now as I solve this, I combine like terms, right? And I can combine 41.4 on the calculator plus 77.2 gives me 100, I'm running out of space here, 118.6 plus Q. That equals 180 degrees. Okay, now this is a one-step equation. I want to get Q all by itself, so I am going to subtract 118.6 from 180. I'm sorry, this is kind of bleeding together. I do that on both sides. That cancels. leaving me, I'm going to write it up here, Q is equal to 180, subtract the angles that we know, which is 118.6, and it equals 61.4 degrees. So we just discovered that angle Q over here is 61.4. Now we can clearly see the question asks, what angle is the smallest? And we could say angle P is the smallest angle at 41.4. Now letter E says which angle will be the largest in the triangle MNO. So I'm going to erase that. I know that M is 28. I know that O is 90. So what is angle N? Okay, another way to think of this, I know that these add up to 180. I know that these add up to 180 degrees, so I subtract the 28.7. I also subtract the 90. And when I do that on your calculator, I hope you're doing this with us so that you practice doing this. 180 minus 28.7 minus 90 is 61.3. So this angle is 61.3 degrees. This one's 90. So it says, which angle is the largest? Angle O is our largest angle in that triangle. Another thing that you can realize is that 90 degrees is half of 180. So if you have a right triangle with a right angle, the 90-degree angle is always going to be the biggest angle in the triangle because you're going to split the other between two angles. Finally, how can angle MON be classified? So again, we're looking at this triangle, and it says, how can we classify this triangle? And we're using this terminology. First off, let's do it with the sides. Okay, the side lengths are all going to be different sides because they have different angles, which means they're all going to be different. So a triangle that has all different sides is called a scaling triangle. So we could write here that this is a scaling triangle. But if we labeled it based on its angles, we know it has a 90-degree angle, so it's also a right triangle. Right? It's a scaling triangle and a right triangle. That's how we could, every triangle we can classify in two ways. Okay, so now let's apply what we've learned here. It says determine the missing angles in the triangles below. It says find angle B. Okay, again, using what we learned, the equation to find this, we know they add up to 180, right? And we have angle A, which is 32, plus angle B, plus angle C. All should add up to 180. And using what we've learned on the equations, we could add 32 plus 81 together, and then we subtract them on both sides. So essentially, you take 180 degrees, and you subtract 32, and you subtract 81, and you'll get your answer. So when you do that, you get an answer of angle B is 67 degrees. Okay, number 3 says find the measure of angle F. Okay, again, we need to remember that E has that square around it, which indicates a 90-degree angle. We would call this a right triangle. And then you have a 45-degree angle. Some of you might realize that 45 is half of 90, right? And 90 is half of 180. So if I take 180 and I subtract 90 and I subtract 45, I subtract the angles I know, it's going to leave me with the angle measurement of what's left. And sure enough, it's 45. So the measure of angle F is 45 degrees. If we were to classify this angle, it'd be a right triangle, but it'd also be a scaling it would also be an isosceles triangle because these two sides are going to be congruent because they also have congruent angles. Okay, let's see here. Find the measure of angle HIG. So again, HIG means HIG. We want to know what this angle is. Okay, the equation would be 58 plus 51 plus angle I is equal to 180 degrees. And you could solve. Okay, another quicker way for now would be to just take 180, subtract 58, subtract 51. You can do all of that on your calculator. And when you do that, you get 71 degrees. So what that tells us is angle I is 71 degrees. And that's our answer. We can always check our work by plugging 71 and do 58 plus 51 plus 71. Does that, in fact, equal 180 degrees? And it should. Okay. Number 5 says triangle JHL has angle HLJ, which measures 65 degrees. The angle LJH, which measures 50 degrees. Draw a sketch of the triangle and determine the missing angle. Okay. It seems harder than it is. All you do is draw a triangle. You don't have to measure it completely, but you put the letters J, H, and L for triangle JHL. And it says HLJ, so HLJ, this angle here is 65 degrees. That's what it tells us. And then it also tells us LJH is 50 degrees. Now, we want to know what angle H is. So we would do 50 plus 65 plus angle H is equal to 180. And when we solve, we will get angle H is equal to 65 degrees. Okay. Great. Again, how I did that is I combined this to be 115 plus H equals 180, and then I would subtract 115 on both sides. Okay, this is our last little bit, and then we'll be done. It says classify the triangles below based on their side and angle. All right, and then it says find the missing angle. All right, so number 6, we notice that it has these indicators here. It says that all 3 of them are the same length. And if you look back in your notes, all 3, based on their side lengths that are equal, are called an equilateral triangle. They all are equal with equilateral. Okay, and angles, they also are going to have all equal angles. Well, in order to figure out what this is, you would take 180 degrees and divide it by how many? 3 angles. 180 equally divided into 3 angles is going to be 60 degrees. There are each of these angles are all 60 degrees. Those are all they're all acute angles, which would make this, do you remember back in your notes? It would make it an acute triangle. An acute triangle. Okay, look at this one here. First off, I can look at the angles, and I notice that this angle is over 90 degrees. It's an obtuse angle, so I know that this angle is an obtuse triangle because of that. And then, in order to know what the side, I need to know what this is, because if this happens to also be 34, then it could be an isosceles triangle. So we got to double check. So how we do that is we're going to take 180 and we subtract the 118, we subtract 34, and when we do that, you get a total of 28. So that means angle X is 28 degrees. It's different than 34 and different from 118. So when you have all angles that are different, it means all sides are different. And we call that a scaling triangle. Finally, here we have GHI. This triangle or square represents a 90-degree angle. So first we could find out what X equals. We do 180 minus 57 minus 90 gives us 33 degrees. This angle X is 33 degrees. I just typed that in my calculator. Okay, when I look at all of these, the 90-degree tells me that based on the angles, this is a right triangle because I have one right angle within the triangle. I also notice that all three sides are all three angles are different, which will mean that all three of these sides, notice how I do different hash marks, all indicate their different lengths. So again, that'll be a scaling triangle because they're all different. Okay? I hope this was helpful and it made sense to you. Go ahead and start working on the homework, and we'll see you later.